Alright, this video is going to be finding the antiderivatives or the indefinite integral of some common functions that show up quite a bit. And so we'll want to make sure that we understand why these are the antiderivatives and of course know what they are so that we can apply them. Alright, the first one here is the antiderivative of 1 over u du. This can also be written as u to the negative 1 du. And this shows up quite a bit. And so when you think about the power rule doesn't work here because you would naturally want to add 1 to the exponent, and that would leave you with u to the 0. But certainly the derivative of 1 is not going to be 1 over u. So that's not going to work. But luckily what we've seen is that the derivative of natural log of u would be 1 over u. So what we can say is, okay, it's going to be the natural log of u plus c. But what you notice is that there's a little bit of an issue with the domain of the function 1 over u and the domain of natural log of u. This function here is undefined at 0, but is defined for all negative and positive values of u. Natural log of u isn't defined for negative values because it's the log base e of u, and so e to some power can never be negative. So this can never be negative. And that would seem to cause some problems because that would mean this function here doesn't have an antiderivative for negative values, to the left of the y-axis. But that runs really contrary to what we've learned, which is that if you have a continuous function, then it has an antiderivative. And so it would seem that there's something we can do here. And what we can do is we can say, okay, well, since you can't have a negative value, let's look at the natural log of the absolute value of u. So that way, even if u is a negative number, we'll still be able to take the natural log of its absolute value. And what I'm going to do real quick is verify that when I take the derivative of this function, whether u is positive or negative, I'll still get 1 over u. So if u is greater than 0, it's quite easy because that means the absolute value of u is just u. So to take the derivative with respect to u of the natural log of u plus c, and that will just be 1 over u. So that checks out. What about if u is less than 0? Well, if u is less than 0, think about what would happen when you take the absolute value of u. U is currently a negative number, and when I take the absolute value of it, it's going to return a positive value. So what could I do other than taking the absolute value of a negative number that would return its positive value? Because I want to rewrite natural log of the absolute value of u in a way that I can actually take the derivative. And the way that you can do this is simply by writing natural log of negative u. Because when you multiply that negative number, whatever it is that u happens to be, by a negative, it will become a positive value. So natural log of negative u plus c. Well, the derivative of the natural log of negative u will be 1 over negative u times the derivative of negative u, which is negative 1. And negative 1 times negative 1 over u is going to be 1 over u. So that works out as well. So we can see here that no matter the value of u, the natural log of the absolute value of u is the antiderivative of the function 1 over u. All right, what about the antiderivative of natural log of u du? This is a little bit tricky because we haven't seen any functions whose derivative is the natural log of u. So we need to think of some way that we can construct a function where when we take the derivative of it, there will be some point where we leave natural log of u alone. And if you think back to the product rule, when you have a product of two functions and you take the derivative of that, each term has the derivative of one function and leaves the other function alone. So let's come up with the simplest product we can, which would just be to take u times the natural log of u. And let's take the derivative of this and see what we get. And this is a nice way to sort of check and then amend your answer based on what you see. Okay, so let's take the derivative of this. So I'll start by taking the derivative of the first function, which will just be the derivative of u, which is 1. So I have 1 times natural log of u, and then plus I'll leave the first one alone, and so it'll be u times the derivative of the second, which is just 1 over u. Okay? So if I simplify this, what I end up with is natural log of u plus 1. So I'm close, right? The derivative of this gets me very close to natural log of u, but I have a plus 1. So I need some other term here that when I take the derivative of it, I'll get negative 1. So if I just subtract u here, when I take the derivative of u, I get 1. So it'll be minus 1, and that'll be exactly what I need. So let's see if this works. Let's make sure that I have my constant of integration here. And I'll just quickly verify by taking the derivative of this now. So there it is. You can go ahead and check my work if you'd like, but we can see now that this is the antiderivative of the natural log of u. A couple more here. These are pretty self-explanatory since e to the u, the derivative of that is just e to the u. And also when you have a different base, a to the u, all we end up with when we take the derivative is we have a to the u times the natural log of a, and so we have to have a natural log of a in the denominator, so that when we take the derivative of this, we're just left with a to the u. All right, let's go ahead and take a look at a couple of examples just to make sure that we understand how to apply these. All right, why don't you go ahead and try these first on your own. Remember, just to verify that you've done it correctly, take the derivative of what you came up with and make sure that when you do so, you get that particular function back. All right, this first one is pretty simple. It's going to be e to the 3x. Now remember, when I take the derivative of this, it's going to be e to the 3x times the derivative of this, which is 3. So I need to divide by 3 plus c. All right, here, this looks a little weird, and this is a common sort of way to write it. If I have 1 over something, dx, I can just write dx over that something. So the way to view this is that I have 1 over 5x dx, and I can simplify this further because I can factor out a constant. So I can factor out a 1/5, right? This is 1/5 times 1 over x dx. So I can rewrite it 1/5 times the integral of 1 over x dx. And now I can just apply the fact that the integral of 1 over x dx is the natural log of the absolute value of x. And so I'll end up with 1/5 times the natural log of the absolute value of x plus c. Now, one quick thing to discuss here is that notice that I factored out 1/5, and so you would think you'd multiply 1/5 by both natural log of absolute value of x and c, but c is can be any constant. So it doesn't matter whether we multiply by 1/5 or not, because you can just choose a different constant to put in there and manipulate it however you want. So it's just pointless to write 1/5 c. All right, down here I can factor out a pi, since that is a constant, and now I'm taking the antiderivative of the natural log of 2x dx. So this is going to be pi. Now, want to make sure that we're sort of careful here, so we're going to take pi and multiply it by the derivative in here. So the derivative of the natural log of 2x is going to be 2x natural log of 2x minus 2x plus c. Okay, so let's just take a look and make sure that this will end up, when we take the derivative of this in here, we'll get this back and we can make any changes if we need to along the way. Alright, so here I've taken the derivative of this. So here I'm using the product rule, so I have 2 times natural log of 2x plus, leaving this one alone now, 2x times 1 over 2x, and since the derivative of natural log of 2x is 1 over 2x times 2, I have to multiply by 2 here, then the derivative of negative 2x is negative 2. So simplifying here, you'll notice that 2x over 2x, so that's going to be 2 natural log of 2x, and then here I'm going to have 2 minus 2. So these will cancel out. That's good. I'm good to go. But I have a little issue here where I have a 2 times natural log of 2x. And so what I've got to think about doing is dividing here by 2. So notice if I divide here by 2, this 2 is just going to go away. And I'm going to have x natural log of 2x, which means that I'll be fine here, right? Because I'll have 1 times the natural log of 2x. But then over here I'll have x times 1 over 2x, right? And so that's going to be 1/2, right? Because the x's will cancel. So I'll have 1/2 times 2, which is just going to be 1. So it'll be 1 minus 2, and this minus 2 comes from this part here. So I want 1 minus 1, so I need to divide by 2 here as well. So that's a little, seems a little complicated, but it actually simplifies this quite a bit because dividing by 2 just eliminates those coefficients that we had there. So it'll be pi times x natural log of 2x minus pi x plus c. Alright, hopefully that was helpful. You won't see too many super complicated integrals or antiderivatives quite yet, but we will be developing some strategies to make some more complex functions integrable with ease.